friends, welcome once more to class online. My name is Mr. Dami, and in this edition, we shall be looking at Jamb Physics 2010, question number 26 to number 30, and we shall be explaining quite a number of difficult aspects of physics that many students find difficult in a way that you can understand and you can cease to find it difficult. Don't forget, if you learn something from this video, click on like button. We have a lot to send to you that will better help you understand physics. Now, number 26 says, during a thunderstorm, the sound is heard over a long time. This phenomenon is referred to as what? Is it refraction of sound, reverberation, superposition, or diffraction of sound? Do you have any idea? Now, that's correct. The answer is simply reverberation. You know, when reverberation is like sound coming back again, it's close to echo, but it is due to, now, what happened is this. If you have a thunderstorm, the molecules, thunder and lightning is the light, is the flash. But thunder is the sound. Okay, so that sound, lightning is just the flash, while the thunder is the sound. But they all come from the same source, the cloud, right? And they are all sent at the same time. But you can hear lightning because light travels faster. And so you can see lightning first before thunder. Because after the flash, then you hear the sound, thunder. So I always do. And when I see the flash, I'll say, now let there be thunder. And some people will think maybe I'm a magician. I know that behind every flash of lightning, there is a thunder sound. And that's because two of them were sent from the cloud at the same time. But light is faster than sound. And that's why lightning comes faster first before thunder. But reverberation is what happens when it kills to what? When you hear it making continually sounding. That is, it is not only that it is sounding again and again, but it is revibrating. It is revibrating, and that is what happens. And that is the answer to that question. It is simply a reverberation of sound. It is not a refraction of sound. It is not a superposition. It is not diffraction. It is a reverberation. The word reverberation may sound like the word repetition, but it is more to the word resonance, resonating sound. It is sound that are moving with the same frequency. Different sound, but are moving with the same frequency. And that is what happened during thunderstorm. And then number 27 says the velocity of sound in air at 16 degrees Celsius is 340 meters per second. What will it be when the pressure is doubled and the temperature raised to 127? Now this is speed, velocity, and this is velocity, and this is temperature. What formula can show you the relationship between velocity and temperature? Can you remember? That formula is simply this. You must have seen this formula before under sound energy. Maybe you might want to check back in your textbook. This formula shows the relationship between velocity and temperature. And so I've seen some questions asking about this formula. And it's always a relationship most times between temperature and velocity. Please take note. Okay, it is clear that velocity is directly proportional to the root of temperature. Those are the two I need. Those are the two I need from the formula. Velocity and temperature are on the same straight line, so they are directly proportional. V is directly proportional to the root of temperature, and that is just it. And that will give me V equals, the root is K. Okay, this constant will become equals to K root T. And then making K the subject, it will become V over root T. Now duplicate it because we have two velocities and we have two temperatures. So that will become V1 over over root T1 equals V2 over root T2. It all came from this one. Okay, and that is what I have here. Now I'm to find what will be the velocity, that's the V2. I've been given V1 as 340 and my T1 as 16. Then I've been given my T2, but I'm to find my V2. So I'll make V2 the subject. If you multiply and you divide both sides by root T1, you'll be getting V2 equals V1 over root T2 over root T1. And that is the, you have made V2 the subject of the formula. Now V2 equals, what's my V1 in the question? My first velocity is 340. And my T2 is 16, right? And that is my T2. T2 is 127 degrees Celsius, right? Now plug it in, but you must change it into Kelvin. So in Kelvin, it will become plus 273. That's to change to Kelvin over your T1. Your T1 is 16. That's your temperature one, 16. But in Kelvin plus 273, and then everything will give me 340, 400 over 289, and that will give me, if you multiply this and you divide by this, you'll be getting 400 meters per second, and that is your velocity 2. It is a directly proportional relationship between velocity and temperature. That means that velocity increase with the root, with an increase in the root of temperature, and the relationship is directly proportional. And that means that the speed gets higher as the body gets hotter. Like if you are boiling water, the water molecules start moving faster if the temperature start rising. So that means as the velocity, as the temperature increase, the speed also what increase, and that's what the formula is simply saying. And that is the answer, 400 meters per second. Now let's see, in comparing the camera and the human eye, the film of the camera function as the what? Now this is the eye of a beautiful lady, right? This is her eye. The film of the camera function. Now the film is the place. Now you can see our pupil and our iris. And then inside at the back of the eye is the retina. And then we have the cornea. The cornea is this layer, this thin skin that covers the entire eye. This nylon that covers the eye is called the cornea. There's a nylon, a layer of flesh that covers the eye first before any other thing gets before the inner part. The outer layer that covers the skin like a nylon, you can't really see because it's somehow it's transparent, is the cornea. Then the retina is at the back inside the eyes. Now, and the image is from, now the image of the camera is from on the film, right? The image of the camera is from on the film. So also the image of that we are looking at in the eye is also from on the retina. This is the eye of somebody, right? This is the eye of Musa. He is looking at this word apple and is thinking of studying the word apple. But the image of the apple is from, it's entered through his eye. The image is from where? At the retina, that is at the back of his eye. Okay, and the image of the apple is from upside down. Can you see that? It is actually upside down. And that's the way images are formed in our eye. Everything that we are looking at are formed upside down. So if I'm looking at a dog, that dog is upside down in my eyes. It is my brain that makes it stand straight. It is, if it is left to my eye, I am seeing everything upside down. So, but all images are formed at the retina, which is the back of the eye. Also, in the camera, all images are formed at the what? At the film. So the film that's on the film, and that's why you can remove the film and go to print it out and get a photograph. So all images are formed on the film in the camera. So also they are formed on the retina in the eye. That is the answer. So the retina is the one that can be compared to the film in the camera. So the answer is the retina, not the pupil, not the cornea. Now number 29 says an object 4 cm eye is placed 15 cm from concave mirror of focal. That should be focal length 5 cm. The size of the image is what? Now you have an object height, object distance, focal length, right? This is a mirror question. First thing first, find, you have been given the object distance, the focal length, you have to further find the image distance. And that brings us to the mirror formula. You know, I've been given object and focal length because the formula for mirror says that 1 over focal length equals 1 over object distance plus 1 over image distance. But I was not given image. I was told to find the image size. But I will further find the image distance first. So I'll just plug in my focal length is 5, my U is 15, plus my V or my image distance is V, and I don't know. So that's my V here. Now then I'm to find my V. So this one will go over from here to this side. So 1 over V will now become 1 over 5 minus 1 over 15. Because this one skipped from here, it's positive, it came here and became negative. And that will become 1 over 5 equal 1 over 1 over V equal 1 over 5 minus 1 over 15. Then the LCM here is 15. 3 in 15 is 5 in 15 is 3 times 1, that's 3. 15 in 15 is 1 times 1, that's 1. 3 minus 1 is 2 over 15, right? Then my V is 15 over 2, which will turn upside down because here is 1 over V. But we are finding V itself, it will become the opposite or the inverse. It will become 15 over 2. It will become 15 over 2 equals 7.5 centimeters. And that is my image distance. Now, how will I find the image height? You must also know that now mirror formula can only help you find distance. It can't find height. Only magnification formula can find height. And magnification says that image height over object height. Hi is what image height. Ho is what object height equals image distance di over object distance. Okay. Now the height, the height is the size of the image. Image height, that's hi. If I multiply this thing, I'll be getting my hi equals di times ho over do. What's my object and my image distance? Here, I have it here. My image distance was 7.5, and that's what I got by the mirror formula. 7.5 times then my object height. The object height was given to me in the question as 4 centimeters. Okay, 4 over the object distance was given to me here as 15, and that is my answer. 7.5 times 4 is 30, by 15 is 2, and that is my image height, and that is the answer. Don't forget that the mirror formula can only find the object distance and the image distance, but it cannot find the height. Okay, the height can only be found by the magnification formula by equating hi over ho equals di over do. Okay, where hi is the what image height and ho is the object height, di is the image distance, do is the object distance, and that is the answer. Okay, and that is the answer. The answer is just 2, and that is the answer for number 29. 2, that's D. Number 30 says an object is embedded in a block of ice 10 centimeters below the plane surface. If the refractive index of the ice is 1.5, the apparent depth of the object below the surface is what? Now you are given a refractive index and you are told to find depth, the apparent depth, but you have been given the real depth. So now you must know that refractive index is real depth over apparent depth. Refractive index is real depth over apparent depth. What is my refractive index? 1.5. What's my real depth? The real depth in the question is 10 over the apparent depth, which is what? 80, which I don't know. So I'm to find the 80, right? The apparent depth, right? I will multiply, and that will give me 80 equals 10 over 1.5. If you divide it, you'll be getting 6.67 as your apparent depth, and that is the answer for number 30. A, 6.677, and that is the answer. Don't forget, it says refractive index equals real depth over apparent depth, and that is the formula any day, any time when it comes to real depth, apparent depth, and refractive index, and that is the answer for number 30. A, and that brings us to the end of this series. Don't forget, if you learn something from this series and you want to get more content, click on the like button. We have a lot to share with you that will better every answer. Until we see you guys, take care of yourself and bye for now.